Welcome to Ask and Learn.
So in this question, we have to balance the chemical redox reaction. So what we do is once again we will divide the reaction into halves and we will start with part A. So in part A, the antimony reacts with nitrate ions to form Sb4O6. So you can see at first we will balance the antimony ions by putting a 4 here, and now we will balance the oxygen atoms. So oxygen atoms can be balanced by putting water molecules on the left hand side. So you can see like 6 oxygen atoms on the left hand side and 6 oxygen atoms on the right hand side. And now we have to balance the hydrogen atoms. So we will have 12 H positive ions on the right hand side to balance the hydrogen atoms. And now we should balance the charge. So we will have 12 electrons on the right hand side to balance the number of electrons, which is 0 on the left hand side and 12 positive charge on the right hand side. So in this case it's the oxidation reaction, since we are ending up with the loss of 12 electrons. Now the next half reaction is NO3 negative, which goes to nitrous oxide. Okay, and now first we balance the oxygen atoms. So 3 oxygen on left hand side, 1 oxygen on right hand side. So we will add two water molecules to balance the oxygen atoms. And now to balance the hydrogen atoms, we will have 4H positive on the left hand side. And now since we have to balance the charge, we have 3 positive on the left hand side and 0 on the right hand side. So we end up adding 3 electrons on the left hand side to balance the charge, and this is a reduction reaction, since we are ending up with the gain of electrons in the course of reaction. And now since we have to balance the reaction, or we have to sum up the total, the two reactions, what we do is we multiply the reduction reaction into 4, in so that the number of electrons get cancelled. So here the number of electrons are 12 and 12 and they get cancelled, and the overall reaction come out to be 4Sb 4NO3 negative plus, now here in the oxidation state we have 12H positive in the oxidation reaction, and in the reduction reaction we have 16. So 16 minus 12 is 4, so 4H positive. And then we will have Sp4O6 and 4NO, and we will have 8 water molecules here and we have 6 water molecules here. So 8 minus 6 is 2, so 2 water molecules. So since it's the acidic medium, we leave the reaction here, so it's balanced now and we don't have to add any hydroxide ions because it's the acidic medium. Now if you see, the oxidation state of antimony goes from 0 to plus 3. So the oxidation state is increasing, and that's why it's our reducing agent, because it's reducing others, thereby oxidizing itself. And the NO3, the nitrogen, the nitrate ion, the nitrogen oxidation state goes from plus 5 to minus 2. So since that is decreasing, it's the oxidizing agent, since it's oxidizing other by reducing itself. So yeah, that's part A. And now we shall go to part B. So the part B, again it's with manganese and bismuth trioxide. So we'll take two halves of the reaction. So the first half is Mn2 positive goes to MnO4 negative. Okay, and now first we will balance the manganese atom, which is already balanced. So we will start with oxygen atoms. So we will end up having 4 water molecules here to have the oxygen atom balanced, and 8 H positive here to have hydrogen atom balanced. And then we will end up with 5 electrons on this side, since we have 2 positive charge on the left hand side and we have 7 positive charge on the right hand side. So we will add 5 electrons to have the overall reaction balanced, or the overall electrons in the reaction balanced. So since we have since we are undergoing a loss, so this is the oxidation reaction. And now we will start with the next reaction, which is BiO3 negative goes to Bi3 positive. Okay, now we will start with balancing oxygen atoms first. So left hand side has 3 oxygen atoms, so we will add 3 water molecules to have the oxygen atom balanced, and we will have 6 H positive ions to have the hydrogen atom balanced, and to have the charge balance. So this side has 3, right hand side has 3 positive charge, left hand side has 5 positive charge, so we will end up having 2 electrons. Okay, and now we will add it up. So this is a reduction reaction, and then we will multiply this by 2 and we will multiply this by 5 to cancel out the overall electrons. So this gets cancelled, and then we will end up having 2Mn2 positive plus 5 BiO3 negative plus, now we have 30H positive here and we have 16H positive here, so we will end up having 14H positive in the balanced reaction, and then 2MnO4 negative and 5 Bi3 positive, and then we will have 15 here and 8 here. 4 into 2 8, so 15 minus 8 is 7, so we will have 7 water molecules. So this is the overall balanced chemical equation. And now we will look at the oxidation state of manganese 2 positive, which goes from plus 2 to plus 7, which means this is our reducing agent since it's getting oxidized and reducing others, whereas BiO3 negative will go from plus 5 to plus 3 oxidation state, and therefore this is the oxidizing agent since it's getting reduced and oxidizing others. So yeah, that's part B. And now we'll move to part C. So part C says that the iron hydroxide is reacting with lead trihydroxide. So again, we'll deal with two halves of the reaction. So the first half is, so first, the lead atoms are already balanced. We just have to balance the oxygen atoms and the hydrogen atoms. So first, to balance the oxygen atoms, we will have 3 water molecules on this side and 6 H positive ions on the left side. And now to balance the number of electrons, um, uh, oh sorry, it'll be 3. So this should be 3. Yeah, because we have 6 water molecules here and 6 hydrogen atoms here and 3 already here, so we'll just have 3 H positive ions. Okay, and now we have to balance the charge. So this has 2 positive charge, this has 0 positive charge, so we'll just have 2 electrons here to balance, and this will be the reduction reaction. Okay, and now for the other one, FeOH2 goes to FeOH3. We will balance the oxygen atoms first and then the hydrogen atoms. So to balance the oxygen atoms, we'll add 1 water molecule here and then 1 H positive here to balance the hydrogen atoms, and then another electron to balance the charge. So this will be the oxidation reaction since we are undergoing a loss of electrons. Okay, and now we will multiply this equation into 2 to get to cancel the overall number of electrons. So this gets cancelled here, and the equation that we get is, so 3H positive and then 2H positive, which means 1H positive, and then lead plus 2, and then we have 3 water molecules here and 2 water molecules here, so 3 minus 2 is 1. Okay, and now since we have to balance the H positive by adding hydroxide, because this is a basic medium, so we cannot have H positive, so what we do is we add another hydroxide here and other hydroxide here. So since this overall becomes water molecules, so this gets cancelled and the overall equation comes out to be, Okay, so now if you see in the lead OH3 negative, the oxidation state goes from +2 to 0. So it's getting reduced. So basically, this is our oxidizing agent. Whereas in FeOH2, the oxidation state goes from +2 to +3. So that's our reducing agent because it's reducing others by oxidizing itself. So yeah, that's it. Hope